My name is Sridhar Garge. I'm going to be your track coordinator for the track. I head the ProViz business in India, and nice to see some of known faces in the audience. Our first keynote speaker for this track is Phil. Phil is a senior software product leader and one of our key assets at Nvidia as far as the ProViz business is concerned. He is from the business unit, and himself is a software solution expert in 3D design, animation, rendering. So it's basically going to come directly from the BU to you. Phil has told me that his session may be a longer one, so he's going to be here throughout the day today. So in case you have any questions, you can always connect with him throughout the day and network. Great, Phil, all yours. Thank you so much.
Okay, yeah, thanks. I'm Phil Miller. I work hand in hand with Steve Parker, who gave the keynote earlier today. He runs all the development, all the engineering that we produce on the rendering and ray tracing side, and my team actually turns it into products. So when we look at all the technology that we make at NVIDIA for rendering and ray tracing, we really serve three different areas. We serve people that are actually creating applications themselves, usually for in-house use, very specialized applications. We have commercial applications, retail products, things that you might buy from a large software company. And then, of course, we want to serve end users directly in what they can use directly from NVIDIA. So in this room here, how many of you actually are developers that create rendering or ray tracing applications? Okay, several. How many of you actually produce a product that actually ships with rendering or ray tracing in it? A few. Great. And how many of you simply use rendering and ray tracing in your daily use? Great. Okay, so we've got representatives from everybody here. Some people had their hand up 2 or 3 times, which is great. So we'll start here with an overview of what we produce here at NVIDIA. So at the very basic, we start with CUDA. Ray tracing, unlike graphics applications like OpenGL or DirectX, is compute-based. So it all starts with CUDA. Now, while you can create something specifically within CUDA for rendering, we found it was much easier if you had something that was specially designed for it. And this is why we created OptiX. You heard Steve talk about it at the keynote today, about, he was really, why he came to NVIDIA was to create OptiX. And I've been working with him for the last 7 years in producing that. So the OptiX SDK is based on CUDA, and it makes it much easier for you as a ray tracing developer to add GPU acceleration to your products. Pixar happens to be one of our most prominent adoptees of OptiX in tools that they use in their studios. Then we actually produce something, a ready-made solution for software companies to add. So if you don't have the rendering expertise to actually write your own renderer, then we actually have a renderer that you can have ready to use and integrate. And this is the Iray, and it comes with its own SDK. It's a physically based renderer, easy to add onto your application. And it actually is built upon the other technologies. So it uses CUDA directly, but it also uses OptiX, because we find OptiX ourselves much easier to use than using CUDA itself. And then we have something called MDL, Material Definition Language, that's part of Iray, but is also available to other people in form of an SDK. Now, we start to make this possible with end users, first of all, through the materials and through libraries of things that people can use. And this starts with vMaterials and MDL. We are then bringing this directly to end users in the form of plugins. So you can add them to your favorite application. And so now you can actually reach from NVIDIA the technology that we're making the very latest. And finally, we tie that all into rendering appliances, things that you can buy directly from NVIDIA that are state-of-the-art in terms of the maximum GPU acceleration possible from a single machine. Now, we also have another renderer called Mental Ray. Mental Ray is becoming much more prominent in the industry now as we are starting to pull away from Autodesk on its availability. We'll go into more about that later on. But the news with Mental Ray is it is also GPU accelerated, and it starts to use some of this technology as well. So in its well, first of all, Iray, if you think about like, why do we have two renderers? Iray is really for the design industry. It's physically based, works exactly the way you expect it to. And then Mental Ray is for the entertainment industry. You can bend the rules, make it do whatever you want it to do. We'll get into more of what that really means a little bit later. Now, as far as building blocks go, as far as the acceleration and GPU acceleration within Mental Ray, it also is leveraging all of this. It uses some of CUDA directly, but mostly OptiX. And then it actually uses the MDL SDK to make materials shareable between Iray and Mental Ray. We are then bringing it directly to end users in solutions, and it also works on our appliances too. Then we have another SDK called Index. This one you might not have heard as much about, but it's really for volume rendering and tackling very large data. By large data, we're talking about in the terabytes of size for visualization. And so really it's for oil and gas simulation, exploration, as well as scientific visualization. And it also is building on some of the building blocks that we have here. Building directly on CUDA, and then coming directly to end users as a plugin for peer review, and then also working wonderfully on the rendering appliances. So let's talk a little bit about some of these technologies, some of you might be familiar with. First of all is OptiX. So the OptiX is not a renderer in itself. It is an SDK for rapidly building a ray tracing application. And I didn't say rendering application because you don't need to be rendering a pixel to be using ray tracing. Sometimes you're doing things like sound propagation or collision detection, explosions, radiation detection, things like that are all ray tracing problems that never actually create an image. OptiX is perfect for all those situations. It does all the heavy lifting for you. If you're familiar with writing an application, if you're doing OpenGL or something like that, the driver and the language does a lot of the work for you. OptiX is very similar to that in being the equivalent of that for ray tracing. Does all the stuff that you don't really want to do so that you can concentrate on building the application that you want. So here's just some examples of OptiX in use. It's used by Dolby for acoustics. It's used by ANSYS in radiation heat transfer. It's used in molecular research by VMD. Any of the people doing molecular visualization are basically using VMD from the University of Illinois. And also being used in games for light baking and other things like that. Custom applications being used in the pipelines that go into making games. Or, of course, to power renderers. I'd like to mention here Furryball. Furryball was a renderer that started out as a DirectX renderer and then actually became a ray trace renderer by using OptiX in just 3 months. So basically they took all their old shaders, moved them over into becoming a ray tracing shaders, and suddenly dramatically changed what that application could do. Jeez. Okay, so if you take I mentioned before that it's somewhat analogous to OpenGL. If you take a look at what OpenGL does, it really is the driver that's, or the language that sits on top of the driver that sits on top of the GPU. As an application developer, you're interested in just creating small little programs that then talk to all of this that result in your raster render. So OptiX is very similar to that. You just have a different type of small little programs. So instead of vector programs or geometry programs, you have intersection, ray generation, close assist, any hit, miss over here for ray tracing. OptiX then is essentially similar to the raster driver doing everything for you. So all the things that you don't really want to do as a developer, all these things over here, acceleration structures, built-in traversal, memory management, working between GPUs, all the stuff that's really takes a lot of work, you all get for free when you're using OptiX. So all of that is handled for you, and more importantly, we evolve it to work as good as possible on our latest GPUs. So as you create an OptiX application, you adopt the latest version, you then get all the new things that we figured out how it would work best on our latest GPU architecture. Now, if you're just doing simple ray tracing, if you're simply making an intersection test, we have something called OptiX Prime. It's very low level. You give us a large amount of triangles and a large amount of rays, and we'll hand you back the intersections faster than anything else on the planet. So about 300 million rays per second on a single GPU. And you can do all of this in about 5 lines of code. It's only about 5 lines of code to use OptiX Prime and gain all of that intersection capability for your application. It can be used in a simple thing like ambient occlusion up in the upper right with mental ray, or in a full-blown ray tracing application down here like with Iray. Then an example of how we make things easier for you as well is automatic support for the appliances. So starting with the Quadro VCA and soon the DGX1, you are able to do remote client-server rendering with OptiX. Your application runs as normal on the client. You then have a version of it running on the server. It then acts as an image generator, sending you back all the images remotely for you without you having to know anything about video streaming, compression, client-server protocols, any of that. All of that is done for you simply by using what is called the Progressive API in OptiX. And then what we showed was the exact same thing running on the DGX1 working with at SIGGRAPH, working with Pixar on their Monsters University campus scene. So if you haven't tried OptiX before, or if you have tried it in the past, you should really try it again. We have a completely brand new version, OptiX 4. This is a new architecture. It is LLVM based so that we can improve it much more quickly going forward and do some more dramatic things with it. Great advances happening with OptiX that really is going to make it the future for the way a lot of applications are written. So now we're going to switch gears. That was all about building a renderer. Now we're going to talk about integrating a ready-to-use renderer. And the one we're going to start with here is Iray. So if you haven't heard about Iray, Iray is a physically based renderer, which basically means it works like the world around you does. You place lights in the scene, you use physically based materials, and you're going to get the result that you expect, much like a camera. So that's one of the reasons we call it a photorealistic renderer, is it behaves extremely like a real camera. It's also being used in a lot of flagship products. Here's an idea of the products that currently ship with Iray as its renderer. Sometimes it's not called Iray, sometimes it's called whatever that application might want to do. Like for example, CATIA calls it something else, Visualize it calls it something else, Siemens NX just simply calls it render, and so on. But Iray is actually shipping as the renderer within all these products, as well as several others internally. Just a couple examples here coming from DAZ Studio, also from DAZ Studio. Iray just being used in advertising. One of these times. Here's one actually being used by Honda within their internal application. Actually, they do all of their quality assurance on the original data coming from their CAD system for inspecting whether it's ready to go or not. Advertising again. Advertising. So again, the workflow is very simple. You take the lighting for a given scene. In this case, it's the lighting in the outside window. You assign the materials that represent it in the real world, and you get a completely photorealistic result. So basically, that's just the in-camera result, no extra post-processing done from using Iray. Iray is then, of course, meant to scale as much as possible. So we take advantage of all the processors within the machine, give you control of what you want to use, CPU, GPU, both. And then we scale outside of the machine as well, across rendering cluster, or coordinating many machines together. Also client-server, having a cluster of machines render back to you, and then across the internet. This is all, by the way, I'm talking about things that are all possible to take advantage of as an SDK developer, something that you would add to your own application. Now, scaling, of course, is something we take very seriously at Nvidia, and we benchmark with Iray to make sure that both CUDA and as well as the renderer are scaling extremely well. So here's just an example with our latest lineup of GPUs, how we're processing and the performance that you're getting with Iray on the GPUs. It's fairly linear with the core count and clock speed for a given GPU generation. So in practice, one of the things that Iray has become extremely successful at is something that we call predictive design, which is an accurate representation of the model before it's built. It's one thing to render something that looks real. It's another thing to really make a design decision from it. This was kind of a Turing test that we did at SIGGRAPH, where we actually had a physical light box, and then we had a monitor next to it. And we had people actually come up and choose which one was actually the real drill, physical drill that you could go touch. And the response was about 50-50 amongst the SIGGRAPH audience, showing that you really couldn't tell. But it's more than just a test. It's actually very useful. So even within NVIDIA ourselves, we use Iray to analyze and predict our designs. Here's the Shield console. One of the things about this design is that it has a light pipe. And the challenge here is that you've only got 4 LED sources, and how do you construct the plastic so it scatters properly and gives you a linear light source? So you're not using a rendering trick of going and making that emissive and have it glow. No. What this is actually doing is putting 4 real LED light sources and letting it scatter and letting it reflect back so that the designers will know if their design is correct. And this has solved a real big problem of reducing the amount of prototypes that our designers have had to do. They used to have to do dozens and dozens of prototypes in order to see, because otherwise it was just guesswork. What is it going to look like? And now they can actually experiment digitally, and the number of prototypes they make are much less. What we didn't want to do prototypes on, for sure, was the building that Steve described in the keynote. So this is our new headquarters building. It was actually a very challenging project because of the amount of natural light that was being used within it. And the goal from our CEO, Jensen, was if you're in this in the daylight, you should never have to turn on a light switch. You've got so much natural light that how can we really take advantage of it? And that became a real challenge, not just for the amount of light, but for the quality of light, what the space was actually going to be like. So we really simulated this building like we simulate our own GPUs and analyzed it completely. Now, one thing about Iray from an SDK standpoint is that it's actually a collection of renderers. It actually has 3 modes, photorealistic on the right, Iray interactive, a very fast ray tracer in the middle, and then actually OpenGL called Iray real-time on the left-hand side. So you can actually choose what type of mode you want to be at any time and even blend between one. For example, you could start off in fast ray tracing for interactive work and then mouse up, blend over into the photoreal. Now, holding that all together is actually the material definition language, because you don't want to have to author for every single environment. You want it just to make the assignment once and for it just to do the right thing in every single mode. That was actually really hard. And MDL made it all really easy for us because the renderer only has to understand MDL once, and then it just does the right thing with it from then on out. Here's an example of it in use. This is actually Iray real-time, interactive, basically direct illumination, just simulating GI, doing fakes. And then this is the true photorealistic result here. I'm going to go back here a minute, back and forth. Okay, so here's basic ray tracing. Then again, there's path tracing, and I advanced too much again. Sorry about that, this is hard. Okay, back and forth. One thing you'll notice is that the reflections around the headlights change quite a bit, and up in the because of the amount of refraction going on, but otherwise the materials in the scene are rock solid. That's all because of MDL. So we didn't want to keep MDL just with an Iray. We really designed it with an idea towards that it could be used by any renderer. We had to use it between our modes, but let's have other renderers use it too. So we created the MDL SDK. And the MDL SDK is so that materials can be used between any physically based renderer as well as lights. And this is being proven first in our own mental ray renderer. V-Ray will be shipping it this winter in their renderer. Algorithmic is already doing it for material workflow, and Adobe has announced support for it in an upcoming unannounced project. The specification has been public for about 2 years, and then the MDL SDK makes it much easier for people to adopt it within their renderer. The way it works is you work with building blocks, in this case BSDFs, that define what the material is. Here is for how they're distributing the light, and here it is for emissive and transmissive materials as well. You put all these together into layers, and you can create very complicated materials that previously would have been custom shaders. Here's an example of it actually being used by an end user constructing a highly layered material within 3ds Max. Here are some examples within the Substance Designer product. These are all MDL materials, all created within Substance Designer. These are single materials. This is basically a swatch on a single plane. So now we're going to talk about how the SDK can be used for end users. So actually bringing it to end users. So while we want to serve as many companies as possible, I'm very proud that Siemens is going to be shipping Iray later. In their flagship product NX. The opportunity to do that only comes around like once a decade, if we're lucky, to be able to be a part of a product. So what we wanted to do was actually bring our solutions to people as quickly as possible and evolve them as quickly as possible. So starting last year, we started creating plugins for them for the most popular DCC products as well as for Rhino. And then also an Iray server product for distributed rendering between them all. Our goal in making these plugins was to make them as integral as possible, really expose how interactive Iray could be in the workflow. This, for example, is actually your Maya interface. That's your real viewport using the IPR viewport within Maya. Just as an example, here are other examples of that project being done within Iray. Here is the Rhino viewport. Again, taking that over. This is your real viewport. Even going back here, this is actually the viewport, and more importantly, this is interactive. I could click on this and rotate it. Then, of course, we're within 3ds Max as well. If you're familiar with 3ds Max, there already was an Iray mode of mental ray in there. This plugin actually exposes the true power of Iray. Also, what we did within 3ds Max was actually show you the simulation capabilities. You can do full lighting simulation. Here, for example, you can see the caustics coming down here on the street. But more importantly, you can actually see with illuminance the actual lighting levels. So you can actually see how much light was at any point. And in this case, you could actually see how much heat was being generated. So all these plugins actually coordinate with one another and across the network with something we call Iray Server. Iray Server is for distributed rendering as well as for interactive streaming rendering. And then we, of course, work with our VCAs too. So all these products work together, and basically you can make Iray go as fast as you want it to. You just keep on adding hardware, and it will keep going faster. Then, of course, materials. The materials can all be exchanged between all these plugins, as well as our vMaterials library. So vMaterials is something that we created because once we found that having a physically based materials system was only as good as the accuracy of the materials themselves. What we found is that most people were spending so much time basically arguing over whether a material was right or not. So we now have vMaterials with over 1,000 materials that are as accurate as we can make them. We have a dedicated team at Nvidia. That's all they do is make very accurate materials based upon physical specs and measurements. that give people a great starting point for building their own custom-made materials. So it's free for everybody. It's free for any application that uses MDL. You'll be able to use this with Chaos Group V-Ray later this winter, for example. Now, one of the other reasons that we wanted to make the plugins was so that we could evolve them as quickly as possible. And evidence of that was that the VR experiences that Steve talked about in the keynote, we were using them internally, and we wanted to bring that to other people as fast as possible. So as soon as they became part of the SDK, the next month we produced the plugins that all used them. So here's an example. All the plugins today can actually do what are called VR snapshots. So single-click stereo output, left and right eye. You can have panoramas from any of the plugin products that we have. That's very simple, consumable on basically any device, cardboard viewer or something like that. Then what Steve was mentioning before was something that we called the true Iray VR, which is light field generation. This is where we take a multitude of camera positions, put them together into a space that you can actually navigate, and now you've got a complete photorealistic experience for which you can really understand your design. And the way that works is any application that can send a job to the VCA or DGX, basically supporting our Q system, can, without any modification to the application, create light fields. So you send a job to the Q. On the Q, you go and change it to be a light field job, and then you have something that you can then view on a high-end workstation. Now we're going to switch renderers. We're going to go and talk about Mental Ray. Mental Ray has been a standard in the industry for over 20 years. It's been used on any number of motion pictures. And what's important now is that it's coming directly from Nvidia. What you may have known, if you know is that the Autodesk products, is that earlier this year, Autodesk bought a company called Solid Angle that came with a renderer called Arnold. And naturally, Autodesk is starting to use that renderer within their products. So Mental Ray has been the default renderer within Maya for the last 12 years. But as of last July, it's no longer included. So what we've done is we're working with Autodesk to take ownership of that back over and offer it directly to end users right from Nvidia. So actually starting today, it's available for everyone to acquire. We're starting to sell it today. It's been in beta since February with over 1,000 sites. It's been very popular beta. And once we got that integration back from Autodesk, we were able to do things to the workflow that we've been wanting to do for years. So Mental Ray's really been trapped in Autodesk for all these years. That's why you haven't heard about it much from Nvidia. We could not control it. It was trapped. It was in our products. It evolved the way that Max and Maya and so on wanted to use it. But now it's being liberated. And starting with Maya, we are able to now really do things that we wanted to do for a long time, like make it interactive, make it GPU accelerated. Now, what's really interesting, the challenge is that Mental Ray has been used for all these years. People have depended upon it. How do we keep that going? And still actually make enough money so that we can keep it as good as possible. To begin with, it is free. So while you're working within Maya, it is going to be entirely free for use for all of your creative decisions. We then only charge for it when you're actually doing production rendering. So if you can actually render your shot, or if you're only doing still rendering, it's always going to be free. But if you're needing to do a long animation, if you're doing a production with it, you will need licenses for your render farm. That's how we're splitting the difference. So people who are, you can always trust that the colleague can use it, that the people that you're working with can be able to use it, that students can train on it and use it. That'll always be available from Nvidia with Mental Ray. So what actually is it? What's the same? First of all, we have all the same functionality that we've had for the last 12 years. It is the most highly functional renderer within Maya, and that includes Arnold. And so all of the scenes that depended upon mental array for all these years will continue to be able to load and continue to be able to work and improve by working with the new plugin. We're also supporting all the old, I'm sorry, not old, but all the operating systems that Maya currently does. But now we can evolve it at our speed. We're no longer locked to the development schedule of Autodesk. We can improve it as much as we would like to. We are supporting multiple versions with our latest. So we'll be supporting 3 versions and letting you choose what version of Maya you want to run it in. You'll no longer be trapped on having to upgrade your Maya to get the latest mental array. And we've made it totally interactive. So we made it progressive, like our Iray is. It gives you feedback. It's totally interactive within the actual Maya Viewport 2.0 system. You can actually click, work within there. And the concept of using remote client-server rendering is all in there. So what used to be called mental array standalone is now included. You can choose how you want to render with mental array, whether it's with Maya or without Maya. It doesn't really matter anymore. And most importantly is a new GI system called GI Next for global illumination that is really simple to use, one quality slider, and then is also GPU accelerated. And by GPU accelerated, we mean really GPU accelerated. So this is all using OptiX for its GPU acceleration. And by adding a single GPU, adding one of our current flagship P6000s, we are now nearly 12 times faster than a 14-core CPU. Now, what's really interesting is the new GI Next is already twice as fast, 2 to 4 times as fast as the old GI that was in mental array. So suddenly, in 1 year, by adding 1 GPU, you can go about 24 times faster, which is basically turning a day render time into an hour or an hour into a coffee break. It is now very, very, very fast renderer, all within mental array. Now, to reinforce, we have 2 rendering solutions. Iray is for the design industry. It is physically based. It works exactly the way you expect it to. This is great for designers who need to understand how their design is working. Mental array, however, is for the entertainment industry. It is for when you need to bend the rules, when you need to make it do whatever you want it to do. You don't care about physics. If it looks right, it is right. That's what mental array is for you. So together, we have a great solution for both ends of the industry, and tying them together is MDL. So materials and lights can be reused between Iray and mental array, and our goal is to make this seamless over time. It's not today. Today you have to do reassignment, but we hope that we can make that seamless over time. So I see that I'm running out of time here, so I'm just going to mention really quickly Index. Index traditionally has been used by the oil and gas industry. We developed it with Shell. But it's also being used for scientific visualization. Here it's actually seeing what a rocket engine, how it performs. Seeing this animated is amazing. This was also done on 128 nodes of the Titan supercomputer. But we're making it so that you don't have to be Shell or a large company to use it. You can actually get the plug-in for ParaView for free. It uses all the GPUs within your machine. Whereas in Iray, we take and we go faster by adding machines. In other words, we're increasing speed. With Index, we increase size. So we pool the memory between all the machines together and are able to handle a much larger data set interactively. So kind of the inverse of how we use the GPUs, but that's really tackling a different problem. But totally available for use with India. With Index. So I'm sorry I'm out of time, but I'm happy to answer questions after. I don't want to steal too much from our next presenter. Thank you.